Hello students, this video is on the topic test for QA available on Bodhee Prep. The tests are designed to help you evaluate your performance topic wise. So once you cover the basic concepts of a topic, you go through the test. With every test, there is a video which gives you the solutions and a brief analysis of what would have been a good attempt in terms of time and questions. There are 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure to download the app and make the most of these tests. This video specifically is on the topic trigonometry. This is the fifth test that we are discussing. In terms of analysis, the test was about a moderate level of difficulty and about 6 questions net correct would be a good attempt. The overall time required for this test would be somewhere around 20 to 22 minutes. In this time, we'll be able to go through the 10 questions and get ourselves the 6 easy ones to get a 95 plus percentile. If you look at the questions, question number 1 says cosec theta minus cot theta is equal to P. We have to find the value of cosec theta. Now we know that cosec square theta minus cot square theta. 1 minus sine square, cos square minus sine square, 1 minus cos square is equal to 1. This is nothing but cosec theta plus cot theta, A plus B into A minus B. This value is given to us as, this is 1, sorry. Cosec theta minus cot theta is given as P, therefore cosec theta plus cot theta into P is equal to 1, or cosec theta plus cot theta is equal to 1 by P. We have to find the value of cosec theta, so we add these two equations. Cosec theta plus cosec theta gives us 2 cosec theta minus cot theta plus cot theta cancel out, P plus 1 by P. And therefore the required answer for cosec theta will be 1 by 2 of P plus 1 by P. 1 by 2, option A becomes my answer. Again, I'd say moderate level of difficulty question, about at most 2 minutes to solve. Tan of 1 degree, tan of 2 degrees, tan of 3 degree, and so on till tan of 89 degree. Now, this can be rearranged as tan 1 into tan 89, tan 2 into tan 88, tan 3, tan 87, and so on. The last 3 digits in such a rearrangement will be tan. The sum of the two numbers is 90, 44, tan 46, and then tan 45 alone. If you look at this product, tan 1 into tan 89 can be written as tan 90 minus 1, and tan 90 minus 1 is in the first quadrant. Because of 90, tan becomes cot. So this will be tan 1 into cot 1. Similarly, tan 2 into tan 90 minus 2, which is cot 2, and so on till tan 44 into cot 44, and then tan 45 as it is. These two terms, tan and cot, will multiply to give us 1 because cot is 1 by tan. Similarly, 1, 1, 1, and so on. The value of tan 45 is 1 as well. And therefore, this entire product will be 1, which is option B. I think this is an easy question, not more than a minute and a half to solve. If cosec square theta is equal to 4xy upon x plus y whole square. Now, we know that the value of cosec square theta will always be greater than equal to 1, because sine theta lies between -1 and 1. Therefore, the inverse will lie beyond 1 and -1, and squaring will make everything positive. This further means that 4xy upon x plus y whole square is greater than equal to 1, which further means that 4xy is greater than equal to x plus y whole squared. Since it is square, so positive, therefore can be cross multiplied, which means x plus y whole square minus 4xy is less than equal to 0. X square plus y square plus 2xy minus 4xy is less than equal to 0. X square plus y square minus 2xy is less than equal to 0, which means x minus y whole square is less than equal to 0. But a square can never be negative. It cannot be less than 0. So the only possibility here is that x minus y whole square is 0, which means x minus y is 0, which means x is equal to y. So this will hold true only when x is equal to y. Option C. I will call this a difficult question because you will have to start from the range and then work upwards. 2.5 to 3 minutes to solve. Sin 300, tan 240, sec 420, cot minus 315, cos 210, cosec 315. So let us write each angle one by one. Sin 360 can be written as sin 300 can be written as sin 360 degree minus 60 degree. Tan 240 can be written as tan 180 plus 60. Sec 420 can be written as sec minus 360 minus 60 upon cot 31 minus 315. Oh, sorry. Cot minus 360 plus 45 cos 180 plus 30 cosec minus 360 plus 45. 360 minus 60 will be fourth quadrant. So sine negative. 360 sine 360 sine remains sine. So sine minus sine 60. 180 plus 60 is third quadrant. Tan positive. So tan 60. Sec. Minus 360 minus 60 will be fourth quadrant. Sec will be positive. So sec 60 upon minus 360 plus 45 will be first quadrant. So cot 45. Cot 45. Cos 180 plus 30 is third quadrant. Cos negative. So minus cos 30. Minus 360 plus 45 again is first quadrant. Cosec positive. Cosec 45. Minus sine 60 is minus root 3 by 2. Tan 60 is root 3. Sec 60 is 1 by cos 60. Cos 60 will be 1 by 2. So this becomes 2. Tan 60 root 3. Cot 45 will be 1 upon tan 45, which is 1. Cos 30 will be minus root 3 by 2. Cosec 45 will be root 2. So 2 and 2 cancel. Root 2, here we have root 2. Root 3, negative cancel. So we are left with root 3 upon 1 upon root 2, which will come out to root 3 into root 2, which is root 6. This here goes here and gets multiplied, and therefore option C becomes my answer. Moderate, easy to moderate level of difficulty. There are 6 terms which have to be found out. So that might take some time, about 1.5 to 2 minutes to solve. Length of an arc which subtends angle 18 degree at the center of radius 6 is. Now, we know that 180 degree is equal to pi radian. Therefore, 18 degree 1/10 will be pi by 10 radians. Now, length of arc will be angle subtended at the center upon total angle in terms of radian will be 2 pi into the circumference, that is 2 pi r. 2 pi cancel. We get the value as pi r by 10. R is 6, therefore pi into 6 by 10 divided by 2, 3 pi by 5 becomes my answer. As long as we know the conversion, easy question, not more than maybe a minute and a half to solve. If x is real and x plus 1 by x is 2 cos theta, then cos theta is. This is what we'll use to solve or get our answer. X is real. Now, if we rearrange this expression, you'll get x square plus 1 is equal to 2x cos theta, which means we have a quadratic in x. Now, for this quadratic x to be real, the discriminant has to be greater than or equal to 0, which means b square minus 4ac, minus 2 cos theta b square minus 4ac has to be 0, greater than or equal to 0. X is real. So 4 cos square theta minus 4 is greater than or equal to 0. Divide by 4 cos square theta minus 1 is greater than or equal to 0, or cos square theta is greater than or equal to 1. But we know that cos theta lies between 1 and minus 1, and therefore cos square theta will lie between 0 and 1. We need cos square theta to be greater than 1, which means the only possibility is that cos square theta is equal to 1. If cos square theta is equal to 1, cos theta could be either plus 1 or minus 1. Option C becomes the answer. Moderate level of difficulty would have seen similar questions earlier. Moreover, the quadratic part gives me a good starting point. Therefore, about 2 minutes to solve moderate question. Which of the following is correct? Sine 1 degree, sine 1 radian are being compared. Now we know that pi radian is equal to 180 degree, which means divided by 3.1. For 1 radian is equal to 180 by 3.14 degree. This will come out to approximately 180 by 3.14. 50 point something, 57 to be approximately 57 degree. So 1 radian is equal to approximately 57 degree, and therefore sine 57 degree should be equal to sine of 1 radian. We know that sine of 1 degree is less than sine of 57 degree because from 0 to 90 value of sine increases. Therefore sine of 1 degree has to be less than sine of 1 radian. Option C. Since radian is not very frequently used, therefore I am saying difficult question. Figuring it out might take some time. Which of the following is true? Tan of 1 radian is 1. Tan of 1 radian is equal to tan of 2. Tan of 1 is less than 2. Tan of 1 is greater than 2. Tan 2. Now we know that tan 45 degree is 1, and therefore 180 45 by 180 pi by 180 by 4, pi by 4. Tan pi by 4 is 1, so tan of 1 will not be 1. If we compare tan 1 and tan 2, now pi radians is equal to 180 degree. So 1 radian is equal to 180 by 3.14. 180 by pi, which is approximately 57 degree. Therefore, tan of 1 is nothing but tan 57 degree. Tan of 2 will be tan of 57 into 2, approximately 114 degree. This is in the first quadrant, so this will be positive. This is in the second quadrant, tan 114. 114 is the second quadrant, tan is negative. This has to be negative. So tan 1 is positive, tan 2 is negative. Therefore, positive value has to be greater than negative value. Option D becomes my answer. Moderate level of difficulty once we understand radian. About a minute and a half to 2 to solve. The value of cos square theta plus sec square theta is always. Now, cos square theta is a positive value. Sec square theta is 1 upon cos square theta. And for any positive number, x plus 1 by x is always greater than equal to 2. Am greater than equal to gm. X plus 1 by x upon 2 will be greater than equal to root of x into 1 by x, which means x plus 1 by x is greater than equal to 2. Hence, this value will always be greater than or equal to 2. Out of the option, this is the best suited option. Therefore, option D becomes my answer. About A minute and a half to solve. If sine alpha is 2pq upon p square plus q square, we have to find out sec alpha minus tan alpha. 1 upon cos, sine upon cos. If sine alpha is 2pq upon p square plus q square, cos alpha or sine square alpha can be written as 4p square q square upon p square plus q square whole square, which means 1 minus cos square alpha. This is sine square alpha is 4p square q square upon p square plus q square whole square, and therefore cos square alpha is 1 minus 4p square q square upon p square plus q square whole square, which becomes p square plus q square whole square minus 4p square q square upon p square plus q square whole square. Therefore, cos square alpha is nothing but a plus b square minus 2ab is nothing but a minus b square. So p square minus q square whole square upon p square plus q square. And therefore cos alpha will be equal to taking the root p square minus q square upon p square plus q square. Therefore, if you look at sec alpha will be opposite of this, or inverse of this, p square plus q square upon p square minus q square, and tan alpha will be sin alpha upon cos alpha. This will come out to 2pq upon p square minus, p square, 2pq upon p square plus q square, p square minus q square upon p square plus q square. So 2pq upon p square minus q square. Therefore, sec alpha plus minus tan alpha will be equal to p square plus q square upon p square minus q square minus 2pq upon p square minus q square. P square plus q square minus 2pq becomes p minus q whole square. In the denominator, we have p square minus q square, which becomes p plus q into p minus q. P minus q gets cancelled, and therefore the required sum or the difference becomes p minus q upon p plus q. From the options, option A seems to be the best answer. Again, I'd say moderate question, about 2.5 minutes to solve. If you look at the overall test, looking for 6 questions in about 22 minutes. For me, the 6 questions would be 1, 2, 4, 5, 6, 9. Which are these? I would do this because I've done similar question earlier, value-based question, therefore doing it. May or may not happen. Value-based questions are doing it. The conversion was simple, radian-wise, therefore would have attempted this question as well. Again, x is real was the trigger point which said, this answer can be done because there is a quadratic, we're just checking for discriminant, therefore would do this every time in the exam as well. Radians, I am not sure, therefore not considering this. This could have been done. We clearly see that we get the form of a plus 1 by a. AM is greater than equal to GM, and this kind of a question has been asked a lot of times in CAT as well. This again may happen, may not happen, not counting it as one of the 6 easy questions. So for me, my 6 easy questions every time would be 1, 2, 4, 5, 6, and 9.